All right, welcome everyone. We're back for the second part of our Tech Week panel. This one called Space for Planet Earth. And we're going to be looking at the applications of space technology across the board and from oceans to the cryosphere to the atmosphere and fire tracking and all sorts of variations. And as part of this panel, we've got 5 panelists. I'll introduce them in a moment. And we have a 1-hour discussion here at the Turanga Library in Christchurch. So I'm Paat-Dahlstrom with SpaceBase, and SpaceBase is a social enterprise promoting space activities in New Zealand. So what this panel is going to be talking about both how space technology is being used today for all these different issues, what things are changing as we deal with climate change, also what are some of the challenges that we're facing today, and what potentials we see in the future as new technologies. So let me introduce some of our panelists here. We have Ilse Pretorius from Scion Institute, atmospheric scientist. She specializes in atmospheric transport. Research activities include fire weather, atmospheric coherent structures, and the development and testing of a real-time wildfire decision support and smoke forecasting system for New Zealand. We have James Nicotine, founder of Blue Cradle. He's a French and British marine scientist, filmmaker, and consultant. For nearly a decade, he has worked on globally in ocean science and policy communications, high seas governance, microplastics pollution, climate change impacts, deep reef research, ocean risk, and marine protected area management. Kate Melnick is a PhD student, is working on a PhD in fire engineering at the University of Canterbury, researching plant flammability in the rural-urban interface. She has a background in plant biology and ecological restoration and work experience as a wildland firefighter both in Canada and New Zealand, and a rural fire researcher at Scion. And Kurt Jansen is founder and CEO of Orbica, Christchurch company, geographer and geospatialist by trade. He's a passion for emerging technology, innovative solutions, and location data. He's a bachelor's in geography from UC and was the New Zealand SEA Young Professional Year in 2016. And he established Orbica in February 2017. Lots of machine learning applied to remote sensing data in his company. And Wolfgang Rack is an associate professor at the University of Canterbury. He's an associate professor for glaciology and remote sensing for Gateway Antarctica, the University of Canterbury. His research focuses on mass balance of the Antarctic ice sheet and sea ice. He spent 15 seasons in Antarctica for satellite validation measurements of the Antarctic cryosphere. So I think we might just go in order across this line for talking a little bit about what your experience has been using space technology, and what and we can later on we can get into discussions of the challenges and future opportunities. And I'd like to remind people in the audience here that we're collecting questions with this Slido app, as well as people online, and it has the code. I think we've already shared that in the chat and online. So Ilse, would you like to say?
Sure. So thank you so much, firstly, for the opportunity to be here. I'm very excited about my job, and so I hope I can get some of that enthusiasm and excitement through to you today. So I work for Scion. I put up a banner over there. Not a lot of people know what we do. We're a Crown Research Institute, and the mission of Scion is to enhance New Zealand's prosperity, wildness, and environment through trees. So really what we do is we do...
Oh,
thanks.
yeah, sorry.
Thank you so much. There we go. Hopefully, is that better? Oh, should I turn it on? Oh, it is on. Great stuff. So we do research in the forestry space. And so in Scion, satellite data is used to monitor forest health, but it's also used in the wildfire space. And now I am one of the members of our Fire and Atmospheric Sciences research group. So today I can talk on wildfire specific themes. I can't really speak for the forest health part. And in the wildfire space, we at Scion use satellite data for a number of applications. And I should say, when we think about wildfire, and of course, the reason I'm talking about wildfire, it's related to climate change in the sense that all of the climate projections that we see generally predict that we'll see an increase in both the number of wildfires and their intensity in the future. So wildfires may become a problem for New Zealand, and we are seeing more and more fires in the last couple of years, and bigger ones as well. And so in wildfire or emergency management, we often speak about the 4 R's. So you have readiness, reduction, response, and what's the last one? I've got some cheat sheets. Readiness, reduction, response, and recovery. And internationally, satellite data is used across those 4 R's. New Zealand is playing catch up a little bit. We are using either currently using satellite data in some of the R's, or we are doing development in others. So we are still playing catch up about sort of in terms of what's done as the state of the art in wildfire research and development in the world, but we are catching up. And it's great because we can learn from what other people have done. So I think I'll leave the examples of those types of applications later. I'll leave it at just at the 4 R's. Thank you.
Sure. Yeah, tēnā koutou katoa. Thank you, Eric and Emeline, for the invitation. It's really a pleasure and a privilege to be here during TechWeek. I was quite surprised when I was invited to a space event being a marine scientist. But actually, it makes total sense when you listen to the things that I have to say about that. And so, yeah, Blue Cradle, so I'm from Geneva, from Switzerland, and it's a landlocked country, right? And so growing up, I was always passionate about the ocean, the distant ocean. And so I became a diving instructor, and then I moved to New Zealand, and then I fell in love with the Pacific Ocean and the Great Barrier Reef. And then for me, that was really what led me to do marine science and policy in Edinburgh, Scotland. And then from there, I continued to consult with several organizations, the UN, the International Union for Conservation of Nature, IUCN, and essentially make videos, films about the ocean and how we need to protect the ocean and learn about the ocean and using different methods. And so when I think about space and the applications of space and ocean, the synergies between space and ocean, actually there's quite a lot. If you think of the planet as 71% covered in ocean, we have lots of satellites up there that can provide observation data to a whole bunch of scientific institutions and organizations. For example, the Argo float system, I don't know if you're familiar with that, provides sea surface temperature and essentially CTD, so conductivity, temperature and depth data to back to the scientific institutions. And so we deploy those. There's tens of thousands around the world. That's just one example of how we retrieve data in the oceanic space, and it gets sent back, and we can make informed decisions We can learn about what we're doing to our planets, climate change, warming, but also biodiversity. You think of harmful algae blooms, we can observe those from space. You can think of pollution, oil spills, things like that. So really, there's a lot of applications when you connect the two realms. And I'm thinking also beyond that, if you think of space exploration, we're now thinking of exploring some of the moons in our solar system. I'm thinking of, I think, Io and Titan. We believe that these environments actually are, aquatic environments, and that would probably be where we would find life. And so I think there's a real segue there between the astrobiology and some of the deep sea biologists on our planet and some of the discoveries that they're making. And so what we're trying to do with Blue Cradle is to connect the scientific work that's happening to the people and make it more accessible to understand what's going on and how we are actually responsible for most of what's happening in the ocean, from warming to acidification to deoxygenation. So really fundamental processes that actually make the Earth function as a whole ecosystem. And so if we don't understand the ocean fully, we're going to go and have some serious problems in the future. So just to end on this, I think the opportunities ahead are really exciting because we've got new tools at our disposal. We've got tracking technology. I'm thinking of actually on this panel, Kurt Jansen from Orbica. We worked on a project this year looking at penguins and how we can tag penguins using GIS, Geographic Information System data. And so we can learn a lot more about their behavior in the aquatic environment and actually then implement measures to mitigate threats to the little penguins. But you could take that further and actually, have a whole load of data in terms of biodiversity. I'm thinking of, for example, coral reefs. You think of bleaching events, which are occurring more and more frequently. There's a lot of organizations out there, one of which the Coral Island Atlas, that actually retrieves the satellite data to then see where these bleaching events are occurring, and then actually layers other data sets and does in-field verification. So Blue Cradle, we're hoping to collaborate with these organizations to then translate all this knowledge and science and make it more accessible for the greater public and to educate to ocean literacy. This year is the start of the UN Decade of Ocean Science, 2021 to 2030, because only 20% of the ocean has been explored, roughly. There's still 80% of it needs to be discovered. Bathymetric information, species, we've only discovered 10% of marine species. So we estimate there's between 1 and 2 million species in the ocean. We've only discovered 200,000. So really, I mean, there's a lot of work to be done in ocean. And I'm not saying we shouldn't look at space, but I think there's a lot of connections between the two fields. Also training. Most astronauts who go in space, they train in pools. So I think there's a lot more that I think needs to be explored between those two fields. And I'm really looking forward to this panel to discuss more. Thank you.
Yes, thank you. Yeah, it's interesting that you mentioned, I think Europa, the moon of Jupiter, has a larger ocean than Earth does. Kate?
Hi, everyone. Thank you for the opportunity to be here. I'm very excited about the discussions tonight. And just like Ilza, I'm another fire researcher. Until very recently, I actually was working with Ilza at Scion. And recently I transitioned to the University of Canterbury to do my PhD in fire engineering. So Ilza did a fantastic job explaining the background of how fire is very much related to satellite data and how we eventually end up to be end users, and we greatly benefit from all the data and all the information we get from satellites and remote sensing. And I can speak to two examples that I actually have used satellite data for and am planning to. So one was actually when myself and Ilza were working on a early fire detection project. Basically, we looked at harnessing the power of satellites to be able to detect fires earlier by merging the satellites that have great spatial resolution, but only orbit or only take imagery twice a day over New Zealand, and satellites with poor spatial resolution, but that provide very frequent imagery. And we were able to improve the resolution essentially of the low resolution imagery to be able to detect the fires slightly faster than what is done right now. And another one is with my PhD. I'm currently looking at the flammability of vegetation in wildfire urban interfaces, such as, for example, if you think to fires that happened in the Fort Hills or in the Lake Ohio. So basically trying to figure out how flammable the vegetation is. And most of my project will take place in a laboratory setting, but satellites or remote sensing data from UAVs and stuff like that can potentially allow us to expand the laboratory scale data to actually apply to the real world. Thank you.
Yeah, kia ora. Thanks, Eric. So Kurt, geographer by trade, started Orbica 4 years ago. So we're on the applied side of a lot of this discussion so far. So how do we do the downstream commercial application of this data and make it ready for decision makers, make it applicable to business and government? On the theme of fire, so we've done some stuff with FENS. We're looking at some stuff around cost modeling to understand the cost impact of OHAL, for instance. So satellite fire, satellite imagery, looking back at what did the response look like? How do we make that better next time? And what does it cost us as a company to deal with that? Fuel loading is another good one for in situ risk modeling that would form a lot of what you guys do. If we expand a little further, so if I think some work right now over in Aussie, trying to understand the impact of huge evacuation events. So big disaster hits, how do we use high frequent satellite passover data to understand evacuation procedures? Hey, all the roads are out, we can see the landslips, that means we have to get people there by boat or evacuate people by boat. Or these people are stuck, we need to get helicopters in. So that immediacy for response of whatever that might be, earthquakes, fire, wildfire, Australia, really quite interesting. And one more example would be, there's so many, wildland conifers. So huge, we've all heard about the conifers issue. We have crafted some really interesting models to try and use AI combined with classic remote sensing, which is what I did as a geographer coming through University of Canterbury, to really figure out how we supercharge that stuff to get results really fast. So that has led to AI models that can identify not only if there's a conifer, is the conifer dead? So did the treatments we did last year actually have an impact, a good impact, and how big are the conifers? And where are the new ones? Because where the new ones are popping up, they're dropping babies, they're dropping all the cones. So how do we solve those before the whole valley fills up with conifers? And there's one example down in northern central Otago, 5 square kilometers, I think it was. There was about 147,000 individual trees in 5 square kilometers. So, you know, this is all either aerospace collected drone aerial and/or a fusion with satellite data that allows us to achieve some of this stuff. One last thing to think about, and we noted it here, and I'm talking about a lot these days. All of this stuff, you've got to think about temporal, so time element, cost element, and accuracy, right? So you can't get, as we just discussed, high frequent passover satellite imagery at 30 centimeter. Doesn't exist yet. Maybe in 10 years it will, not there yet. And if it does, what's the cost factor going to be? So just things to think about in all the examples or how we apply it downstream to add value to the economy, society, or environment.
Thank you, kia ora. Thank you for having me here. That's great. We heard about wildfire, we heard about oceans, we heard about penguins, forests. I can talk a little bit about snow and ice, which is my core expertise. So I'm originally from Austria, also a landlocked country, but I got fascinated by polar regions and I did my degree in meteorology in Austria, but I had a chance to go to Antarctica and I had a chance to witness the collapse of an ice shelf, which was in the late 1990s, which was kind of at the start of satellite observation of change in Antarctica. And we need to keep in mind that climate change is a matter of not only emergency, but also of national security. So what is happening on the poles is also affecting us here. What I want to say here is that the sphere of influence of New Zealand is big and large. So New Zealand is a claimant state of the Antarctic, 5 million square kilometers south of 60 degrees south. There are no inhabitants there apart of Scott Base. So it's sparsely populated, to say the least. The only way to really monitor and observe that is using satellite remote sensing. My main core expertise is radar, which is of an advantage for Antarctica because it's capable to observe during the polar night and also through clouds, which is also very important for New Zealand. And I think there is a lot of potential here. My main research at the moment is sea ice thickness. We have excellent sea ice data of the area over the past 40 years. We know the area, how much sea ice is out there. We are still not able to tell how thick it is because sea ice is relatively thin and very difficult to measure from the satellite. We want to multiply the area with the thickness to know the volume and the mass. That is what is important for climate change research. New Zealand and Christchurch is a great place to work on these topics because it's possible to go to Antarctica and to validate the satellite measurements. So that is important to get a good quality measurement out of the satellite data. So we have the opportunity, and we did that in the past, to use aircrafts to fly along satellite tracks and to validate one-to-one the satellite measurement and then to expand that knowledge to the whole area of sea ice, which at its maximum is 20 million square kilometers. So satellite measurement is the only way really to do that. I think I probably leave it with that for now. Thank you.
So I am monitoring the questions on that Slido app if you have any questions, or in the room if you'd like to raise your hand. But one area I think I would just like to open it to the panel is what kind of things have been changing in recent years about access to data or ability to process the data, and at the same time as what has been happening with the influence of climate change is to change the environment that you're working in, or as some of the topics. Like I remember, decades ago, we would have specialized computers to process satellite data that were $50,000, and someday hope to use a Cray supercomputer, but this little phone is actually worth 60 Cray supercomputers. That's the transformation of the technology. And so that is, have you experienced that kind of transformation as far as access to processing of data? Would anyone like to talk about that? Yeah.
Right, access to data, there's a lot more of it, which is good, but also bad, because what matters is what you do with it. However, that's also getting solved with AI, machine learning, deep learning. So there's a couple of Orbicans in the audience here, and they have the best gaming computers in the world, kind of thing, sitting under their desk, so full of GPUs, and they can parallelize 10,000 operations per second to process data. So that's allowing us to process billions of pixels in minutes now, which is pretty awesome. Access, licensing is still there, and license issues, and cost of access is still there. So I think this is where economies or countries or collectives can come together and purchase data as a wider group with more open licensing models. And that would both facilitate all of the research that needs to happen, but also allow commercial and downstream applications to be built to actually apply the research. We've done pretty well in New Zealand with leadership on aerial capture. So plane-based cameras and planes, and that's all open sourced and openly available now. Not so much in satellites, because we don't own satellites, but as a force, we could come together and sort out those contracts as a group, as a country, as MFE, MPI, DOC, working together to procure this stuff.
Yeah, that's great. I just wanted to add that over the past, let's say, 5 to 10 years or so, there was significant change, especially for climate research, about the availability of data. And it kind of started with NASA and the Lancet data to open the Lancet archive. And that fueled development, and it fueled really an industry which can access this data free of charge. And I think that was really a game changer. And also in a way that then the European Space Agency had to react and to do something, and they put into place the Copernicus program. And also these data are now free of charge. Not the highest resolution, but in terms of pixel spacing, but relatively good temporal resolution. And also a huge variety of the data. So since about 5 years, we have now also free of charge for the first time high resolution radar imagery available. And that again is fueling an industry kind of, and the development of algorithms, artificial intelligence, all what we can do with that. And I think so what NASA started, probably it was 12 years ago or so, I think that was a key moment in the development of these algorithms. And just one thing, why in terms of climate research, why are we doing that and why is it necessary and important? I think we are in a unique position now in terms of change, because we cannot only observe change, but we can also prepare this data and to get this data as inputs to computer simulations to predict change over the next decades. And I think that is kind of the hope what we have, that we can visualize and predict change, that we actually then also try to manage how we react right now, and how we can actually things like how can we meet, for example, 1.5 or 2 degrees climate Paris Agreement targets.
Would you like to add anything?
I totally endorse what you said. I think the NASA, Lancet system we use it all the time, which is great. It's a great model for collaboration worldwide. And also using satellite data in models. I mean, obviously, climate models use it. Numerical weather prediction modeling uses satellite input for weather forecasts. And then in New Zealand, we are now developing a real-time smoke and fire growth system, which also has satellite as data input at various steps. One thing that I just can mention with this collaboration and all the data that's being available as a reasonably newcomer, I think, on the stable to the satellite space is that the jargon used in this space is really crazy, and every single sensor on a satellite has a different abbreviation, and for me it was a really hard place to navigate. And so I do think, even though the data it's now so much freer available and stuff, it's a hard place for newcomers to navigate, especially maybe if they don't come from a remote sensing, tertiary background. So I think there's some work that needs to be done in simplifying that, or maybe we should move away from using abbreviations and explain the thing in full or something. I don't know. That's just my 2 cents. Thanks.
It took me so long to figure out what the differences between the Sentinel satellites were. It's like just instead of calling the same thing different names, they called different things the same name. So yeah. James, I wonder if you could talk more about, besides the remote sensing, you were mentioning some of the sort of Internet of Things, picking up data from it started with the big buoys that are out there transmitting, but now it's down to monitoring individual animals that have been outfitted with these transmitters.
Yeah, no, thank you for the question. I think we talked about climate change, but I think the coin has another side, and that's biodiversity. And so we are facing lots of challenges, planetary challenges, which include warming and acidification and loss of oxygen, but also the destruction of habitats of entire ecosystems and species. And so whilst we are focusing on one issue, the other is happening at a faster pace. And so we need to really understand what are some of the causes and mitigate the consequences of the loss of biodiversity and also the connectivity between these species. I'm speaking, particularly marine species, because that's the realm in which we're working in. But for me, there's several things. I think the advent of technology and data and sharing is really is positive, and I think there's a lot of great things there. And the satellite technology and the remote sensing is certainly very helpful. And I think integration with in-field verification devices and also the transmission of information between countries. And so, open shared data is really important and relevant. I think citizen science as well is really relevant when you think of, the ocean and the biodiversity, but also terrestrial information. And I think the future holds many exciting things as we become citizen scientists and we learn more about what's actually happening and how can we mitigate. But I think more importantly, we as scientists, whether we're in the forestry or more in the applied sciences and climate and ocean, I think we should really focus on solutions. And so instead of just documenting and observing, we should really start looking at what are some of the solutions we could actually implement and invest in to reverse the downward trend in our biodiversity and also mitigating climate change impacts. So I think there's we could keep on talking about these issues for a long time, but for me the importance of space is paramount. And I think the opportunities in miniaturization, also smaller and smaller devices, automated systems. I'm thinking of the sail drone. I don't know if you heard of that. That's recently circumnavigated the southern ocean continent. A sail drone, which essentially was an automated device that the designers and the scientists just left to circumnavigate the ocean and sending crucial data from down there. I think there's a lot of opportunities there with the satellite telecommunications, and so sending back the data back to the people that need it to interpret it and then make some models and so on. So I think, the future is bright, but we need to really act fast to work on those solutions.
I have a question from the audience. It said, Kurt briefly discussed the high costs around data because New Zealand doesn't have many satellites, or actually access to the satellites. What types of satellite data are the most valuable to you in New Zealand? All of it.
It completely depends on the problem landscape we're trying to solve for the solutions. So, the stuff we've discussed, Landsat, Sentinel satellites, the freely available stuff, which is awesome. There's a level of granularity that we need to go down the next step, and that's all commercial. And whether it's frequency or, accuracy of data, so pixel size, that's the bit that's still a bit tricky, and where there's a lot of competition going on between aerial capture and drones, depending on scale of operation. So it's an interesting landscape. But really, it ultimately comes down to what's the problem, and then understanding the data landscape and solving to that. And obviously cost and access is a consideration in and amongst that, as well as is what we think actually doable. So that's where the R&D and science aspects come out. I was going to jump in before, I think, and it's been brought up a couple of times, as a geographer and as a data geek, I think it's the relevancy to tell a story that is really important. So biodiversity, we've talked about the impact of climate change, yada, yada. We've done an interesting project for a German not-for-profit focused in Borneo to understand the loss of orangutan habitat. And they were having a lot of issues getting donations. And it's because how do you make that relevant and real to people? So we built essentially a map-based satellite imagery system as a donation platform. And so you can see the plantation, 10 by 10 meter grids, and you go, each grid is €25, and that's going to have it replanted back to its native state. That went live in December, and there were 140, €150,000 through the platform already. That took them 2 years to get to that prior to this. And it's that ability to, it's not like a donation button, like it makes it real. And then we're updating it every 6 months. So you see the new land use change coming up from your donation. So it's, I guess it's not just the raw science of it and the jargon, it's the storytelling aspects and making it relevant to people, I think is really important. So just another angle to think of, maybe. I want to note at some point, so radar from space, we keep dabbling and talking about it. Really interested in understanding that as well from where's it going, maybe Wolfgang, I don't know if you could speak to that, but.
Yep.
Yeah, no, that's a good point. So first, I guess I want to say, no, it's not all about satellites. So it depends on, no, there are no perfectly airborne remote sensing data or drone data, what just does the trick, no? And one of the main problems what we have with satellites is that there is a restriction, and that's the orbit, right? So there is not much choice. It's especially for New Zealand, so it's polar orbiting satellites which deliver actually the high resolution data. And then very often the problem is the clouds. So sometimes really and New Zealand is very good in that, in doing airborne remote sensing and also getting really into drone technology and in covering that space. I think also that airborne remote sensing and drone remote sensing kind of puts a little bit the pressure on the space sector, because no, they deliver actually products at a quality that the space sector, they need to really step up to match that. So, and I think that is a good development. So that kind of competition. In terms of the data availability, I think there is much more what can be done. I agree, it's not all about spatial resolution or temporal resolution. Revisit time is very important. But no, we can do many things together. So recently the New Zealand Space Agency was formed. And no, there is, it is possible to do a little bit more of lobbying to get access to data which often is only accessible for researchers which are based in the European Union or in the US. So now, if we just look back on now again, climate change research, what is my topic? So now the Spot series, a French satellite, high resolution data from the 1980s. These data are only available for EU-based researchers. So that would be very important for the New Zealand Space Agency to lobby that also we get access here to that kind of data. Yeah, so that's probably what I can contribute to that point.
Kate, I know that you were involved in a project that you described, and you were trying to extract information about the start of fires, but it was a geosynchronous weather satellite that you're using, and there, as I understand, there's no fire dedicated satellite or sensors that are, and I just wonder, that seems like a potential future is to change the sensors that are.
That's right. That's right. As far as I know, there is no fire dedicated satellite.
Mm-hmm.
And basically, it would be amazing to have something that's more suitable and maybe even increase the resolution, increase the the temporal resolution as well, like the return interval. Because, for example, with fire detection, satellites are an amazing tool, especially in remote areas where there is no people, so the public cannot report the fire. And with fires, we want to fight fires while they're small, because at that point, if you respond quickly, you can hit it hard, you can extinguish it. Whereas if you give it time, if you give it even a few hours to grow bigger, then it becomes a paramount problem. It becomes so much more difficult. So essentially, yeah, it would be amazing to have something that would allow us to detect fires faster, and then also to be able to monitor the fire growth, to take care of, ensure the safety of firefighters, to be able to know exactly what the fire is doing and where it's going.
Kurt, did you have a different opinion about whether?
No.
Okay.
I'm not totally attuned to this, but there's the Modus satellite. Yeah,
That's
which
right.
is that's yeah.
It's twice.
Yeah, twice a day.
Gotcha.
So what's interesting? So you're thinking about all the CubeSats, right? So the mini doves flying around the planet, sub daily capture of the entire planet. Interesting to think about that from a fire detection perspective and where that's going. Within 3-4 years, there's various constellations that'll be doing 3 hours. Some will have at least an infrared band. I don't know, something to.
That would be cool.
And I think that geosynchronous satellites are ripe for disruption also is, yeah. Let's see, we have another question. What are the biggest limitations today for available data? And what do you wish we have now to help better address the challenges you're focusing on? I guess you talked a little bit about that.
I can maybe answer to this, and also it relates to the previous question. So again, I can only talk for my area of specialization, which I suppose the people have before said we're all a little siloed, and that's hard because just to keep up with your own field takes quite a lot. But one of the limitations definitely for New Zealand is that there are data sets that are freely available globally, but in order for us to use them, and I'm thinking now specifically data sets around fuel or vegetation moisture content, it needs a lot of ground validation, and that needs money. So I'm asking the government or someone to give us money to go and do that research, because that's really a low-hanging fruit. You know, the data set's available, it's free, but we just need to make sure we tune it. We understand it for the New Zealand environment, and that can make our fire growth modeling and also smoke forecasting so much more accurate and believable. So yeah, that's definitely, and I'm sure there must be other examples out there.
Yeah, please.
Actually, just to sort of build on what's been said already in terms of ethics and how we're applying satellites and space capabilities to climate change. So science has this great ability to transcend a lot of the geopolitical barriers that typically get in the way of progress. And I'm curious, where do you see from your respective positions, where do you see an ethics that's grounded in the science that can transcend those sorts of traditional problems and actually get leverage to solve climate change and biodiversity loss? Where's the ethical through line or the leverage points that we want to
So in case the online people didn't hear that, it was about using the power of science to transcend some of the geopolitical issues when we're addressing climate change. And I know you you talked a lot more about the ethics, but would anyone like to? Yeah.
I think there's a huge gap or like imbalance when you think of developing countries, developed countries, and access to, say, satellite data, but it could be also ocean data. And so in the field of development and conservation, especially, you have, organizations, foundations who are trying to address those imbalances by either providing data to the countries that need it for X or Y reason. And in doing so, they're trying to provide a social, an environmental benefit or a social and economic benefit. And those are often, drops in an ocean. But I think on a more sort of moral level, I think at the highest level of governance in terms of ownership of data and space, spatial data. In particular, we need to have a policy of making data accessible even to the ones that don't have the technology to get the data. So thinking of the poorest countries in the world that have often the harshest climate consequences or biodiversity consequences. And so in order for them to solve their problems, we need to really rectify the imbalance. And so that's really tricky because you need some generous northern hemisphere countries often giving away, and there's no such thing as a free lunch. So it's complex, and I understand your point. I think we really need as scientists, once again, really need to put pressure and make these data sets available. And when we're working in the countries, I'm thinking of specifically in our space, the Nagoya Protocol, which is quite relevant. It's a policy instrument under the CBD, which essentially is an addendum to the Convention on Biological Diversity, which forces ratifying countries to be transparent and to give back the data, the DNA data, often that can solve diseases potentially that belong to the indigenous peoples in which the research has been done, or any other setting. So it's about that. It's about data access. And so I invite you to look at the Nagoya Protocol. That's I think New Zealand is a signatory. So there's all those things that I think policy instruments that can help. But I think we need a lot more in that field. So thank you for the question. Yeah.
There's another. Would you like?
Storytelling again, but you can tell many sides of different stories with the same data. So I think it's coming down to that science-based objective storytelling. We talk a lot about the black arts of deep learning and AI and neural networks. We now talk a lot more about white labeling. So what's explainable AI? How can our models be explainable in layman's terms without jargon, so you understand the assumptions going on inside those models? So again, if we spin that up a little higher to a more societal level, I guess, objective storytelling without the political propaganda. Earth observation data, because we all connect with place and you look at it straight away, you can understand a message it's telling you. So in the New Zealand context, across New Zealand, wetlands, for instance, right? Critical, farmland, dairy, nitrates, biodiversity impacts. There's a lot of contention about if that should be released. Where are the wetlands? From a farmer's perspective, do they want that to be done? So again, relevancy, and in that case, if it's the farmer pushing back, well, it's really important we keep biodiversity on your farm for all these reasons. So how do we spin the story differently from a science base to get the buy-in that we're all on this journey together, and use objective data to help make that happen? If they look at it purely from a commercial perspective and they don't understand the science, many will push back. So.
Yeah, no, it's a very good question. So very often, from a climate change perspective, we are kind of still in a safe area. We kind of work very often with data which are relatively coarse resolution, where we are more interested in the larger picture, and we can do a lot with that kind of data. I think we still need to get much better in the visualization of things. No good question. If we come down to very, very high resolution data, very frequently acquired data, there is still surely ethics comes into this whole questions and how we are going to deal with that. I think there is still a lot of to be said about that. It depends a little bit on the country. So no countries or some countries at least in the European Union are more strict about that. New Zealand probably, maybe because there was not so much uptake yet. So that discussion probably still has to be had.
Thank you. There was one sort of a practical question that somebody was asking that maybe maybe Kurt, you could. There was just one. They were just wondering how you filter out things like clouds and math and identifying things like that. I think they might be surprised at how much your AI can distinguish features in the.
Cloud masking and pulling clouds out is easy. There's many ways of doing that over the years. In terms of what you can pull out, simplistically, a way we talk about it in the business is if we can ascertain it as humans and make out by looking at it visually as humans, we can normally get an algorithm trained up to do a pretty good job. Yeah, I was just interested in your what you do with built structures in cities and things like that. Yep. So that starts to come down to, think a building, for instance, there's lots of different pixels or spectral signatures that could make up a building, blue roof, black roof, tiled roof. And that's where AI gets a bit more interesting compared to some of the more classic remote sensing techniques. When we start to look at granularity, nearest neighbors, edge detection, it starts to understand, hey, this building, this outline thing looks about the same, and it's got a shape of a building. We're used to understanding what a building's shape looks like. So these are the sorts of things that are happening under the hood. And that comes back to that explainable AI. How do we take away, there's a classic AI example, which was detecting, I think it was wolves. And, they had this algorithm running at 98% or something. And as it turned out, it was actually detecting snow with the presence of a wolf, not the wolf. And so when something tweaked, all of a sudden there was no snow in the image, it couldn't find the wolf. So again, this is the understanding of the explainability under the hood. Thank you.
I agree. It's relatively easy to detect clouds. It depends a little bit on what we are after and the research question. It is. So if we are looking about cloud reflectivity and so on, it's sometimes surprising how complex things can get. So just recently, I realized, for example, that there is not a proper cloud climatology available for New Zealand, but maybe I'm wrong. Maybe you can help in coming up with that.
We look for all the images without clouds and only source them that way.
So. And as we know from clouds, I mean, it's such important in the climate system. We know that clouds in the Southern Ocean, that's the biggest uncertainty for climate models globally is actually the clouds in the Southern Ocean area. So no, there is still many things to be done because it shows us, again, satellite observation shows us that we do not properly or not completely understand the climate system. Now, our climate models are not able to reproduce the clouds, what we actually observe in the Southern Ocean. So I think that tells us again, okay, what Earth observation, the role that Earth observation can, can play in improving these models. You mean with radar? Yeah, no, well, it depends on what we are after. Sometimes we just don't want to see the atmosphere. We are just interested in the land. And no, you made very interesting comments about jargons and so on. I think you are after very, when you talk about soil moisture, I think, that's a very demanding problem. That's not an easy one to solve. That is probably, the high art of remote sensing to get a soil moisture product. How we're going to do that? Well, I guess it needs it needs artificial intelligence, but it also needs a combination of sensors. There is not one sensor who is going to solve that. So radar will solve some of our problems. What we have, but there are other optical sensors which can solve other problems. I think what we probably, I just put it in here into the mix, what we sometimes often maybe forget a little bit is we are often interested what's happening at the Earth's surface, but atmospheric remote sensing is also a very important part of remote sensing. I think that is still where New Zealand lags a little bit behind, right? So we can do a lot more in atmospheric remote sensing.
Just for the last few minutes, I wonder if you could talk about what you see happening in the future. There are a lot of things like, New Zealand's participation in methane sat, for example, will be happening soon, and there's new initiatives for hyperspectral sensors, and even this week the U.S. government announced a $2.5 billion investment in Earth observing remote sensing. And I just wonder what in your variety of areas, what you see as a potential of what's coming up as far as capabilities or compute or real-time actionable intelligence. Anybody,
So in more general terms, what I'm hoping for to see in the future is to have the satellite data become even more available to basically users in other fields, because such as myself, a biologist and ecologist by trade, I never really thought I would be using satellite data, and here I am, and it's very much relevant to what I do. So basically making it even more available to people who are not necessarily trained in geography and trained in remote sensing to be able to harness the satellite data in their own ways, because the more heads we put towards problems, the more creative solutions we have, and that's where innovation happens. So yeah, that is my hope.
Made some notes on this on my cheat sheet, and I may go a little bit rogue as well. Yeah, I think immediate needs that could be solved, I suppose, reasonably easy is we participated in a workshop with the Australian Fire Emergency Services, and one of their biggest needs are communications during a wildfire event. And so a lot of the fires are in remote areas, often complex terrain where you don't have line of sight, so you don't always have a very good radio operation. So, and one of the people at that workshop was a communication specialist, and so he suggested putting up a balloon over the area, which could sort of remain stationary for a couple of weeks, and that could solve. So I suppose those are really good things. And then yeah, definitely, I suppose the ultimate hope would be increasing temporal and spatial resolution, I suppose. But I think just coming back to the ethics question as well, I think with this increasing data availability, I think we should always just remain conscious as scientists to keep our credibility. I think that's one of the most important things to me. So if we make anything we make available, make sure you state, like you said, Kurt, your assumptions, your uncertainties, and make sure that you can remain credible, because I think in this space, especially in climate change, this environment we are navigating, it's becoming so political. And once you've lost your credibility, it's sort of game over for you, which is so I think being conscious of that. And I don't actually think that scientists are always trying to know what they're up against in the space. I often feel that I'm not. So yeah, that's I think my answer to that.
Yeah, I'll try and answer as well. I mean, for me, the urgency of the situation in terms of climate and biodiversity calls for a plethora of different fast-paced solutions. But I think what comes to mind is really the ability to mitigate and to anticipate some of those consequences that are happening. I'm thinking sea level rise and extreme weather events particularly. So being able to anticipate where those are going to be occurring, at what kinds of scale, and then mitigating those quite effectively through relocating cities. I mean, recently we heard that the Antarctic ice shelf is, we've just had a huge iceberg disconnect. I mean, what we can do with that kind of information is use models, and that's what scientists do. And then we can then understand, well, how much sea level rise are we talking about, and what can we do to mitigate that. So I'm thinking that all of the different fields that you could, like oceanography and marine biology and all the different fields within the field, we all sort of use satellite data in different ways. But I think what we really need to focus on is what's coming next, and so how to anticipate those disasters from happening and saving lives. And so, yeah, I'll just end on that. Yeah.
Can I add maybe something a little bit about the technology and the understanding of the technology? I think we are still often think quite in silos. So now we have the scientists on that at one end and the engineers on the other. I think it would be good to bring the science closer to the engineers, kind of, so that the one group really understands a little bit better the technology, which is getting really quite complex. And on the other hand, the technology side of group understands more about what do we actually need and what do we want to observe and how and what sensors do we need. I think New Zealand is a great place because now we have great engineers, but sometimes I feel kind of a little bit disconnected in a way that sometimes there's a question, we have great technology, what are we actually going to do with that? On the other hand, there's a little bit or not enough understanding from the science side or from the science groups about the available technology. So I think there is a lot of potential here, how we can probably upscale the New Zealand kind of research and technology environments to contribute to better Earth observation at the end, really.
If I pick more of so less technical, but more of a domain space. So we've talked about climate change and then biodiversity. So how do we bring them both together because of the same coin? So, the orangutan example, biodiversity increase, but also carbon sequestration. So what does that look like from the storytelling component? But actually, if we start to get into the analytical side, where's all the marginal land? Where, if we think about the South Guyland High Country, all that marginal tussock land, gorse land that we're running a couple of sheep on, it's not productive, but nobody's doing anything else with it. So how do we identify that, plant it back to natives, regenerate it, biodiversity comes back, carbon sequestration happens, carbon comes down. So again, I'm really excited by that, and I hope we can make it happen, and the politics and the ethics can be dealt with, because we're in a huge issue this century.
Right, thank you. I think that's our time, and let's thank the panel.